In this video, we're talking about the boot process, identify several types of bootloaders. We will describe what the BIOS does, identify the relevant configuration files, and describe how the system shuts down and reboots. Okay, let's begin. Boot sequence. The basic steps in the boot sequence are the BIOS UEFI locates and executes the boot program or bootloader. The bootloader loads the kernel. The kernel starts the init process PID equal 1. Init manages the system initialization using systemd or the older appstart and system VINIT startup scripts. When power is applied to the computer can only perform the operations the BIOS, basic input-output system, orders it to do. First, the BIOS runs the post the power on self-test, which checks the memory and hardware and then searches a specific location or device for a boot program. Typically, the boot program is found in a device's MBR, master boot record, or using UEFI. Control of the computer is then transferred to this boot program, usually grep. The boot program then loads the kernel into the memory and executes it. On x86 platforms and many others, the kernel first has to decompress itself in place. It then performs hardware checks, gains access to important peripheral hardware, and eventually runs the init process. The init process, in turn, continues the system startup running init script if the system v init is being used or managing either appstart or systemd. Newer computers are moving to UEFI, a replacement for BIOS, which performs many of the same functions. BIOS. On the x86 architecture, the BIOS contains all the code required to gain initial access to the keyboard, display screen, disk drive, serial communication, a number of miscellaneous functions once the full system is running. Most of these devices will have enhanced capabilities when complete and specialized device drivers can be loaded and take over. The BIOS is typically placed in RAM chip that comes with the computer. It is often called a RAM BIOS. This ensures that the BIOS will always be available and will not be damaged by disk failures. This also makes it possible for a computer to boot itself. During the boot process, the BIOS loads the bootloader. Bootloaders. There are all different kinds of bootloaders, right? Grab, EFI boot MGR, Lilo, DSU boot, I'm gonna explain them one by one. We start with the grep. Virtually all non-embedded modern Linux distributions using grep. Grand Unified Bootloader. Grep's features include the ability to boot multiple operating systems, both a graphical and a text-based interface, allowing ease of use over a serial cable, a powerful command line interface, or interactive configuration, network-based diskless booting, and other advanced features. EFI Boot Manager. EFI Boot Manager is not actually a bootloader, but is a boot manager used in conjunction with the grep on multi-boot EFI systems. Lilo. The Linux loader, LILO, is old and obsolete. Dash boot. Dash boot is in wider usage of embedded systems. There are some other bootloaders used, including bare boot. However, we're not focused on embedded systems in the present video. Configuration files in etc. Earlier, we discussed about where Linux distributions cooperate and hopefully follow agreed upon standards to place certain kinds of files in standard places on the system. In particular, system-wide configuration files are generally placed in etc and its subdirectories, while user-specific ones are often placed in their individual home directories. This is not completely true. For example, default configuration information might be stored in a user lib systemd, but can be overridden by files in etc systemd, right? For historical reasons, Linux distributions involved their own rules about exactly where to place some information in etc. For example, all Red Hat derived systems make extensive use of etc system config. Well, Debian-based systems have used the etc default, interestingly. Red Hat Enterprise Linux and SUSE use both. There should be only text files found under etc, no binary formats or data. etc sysconfig files in this directory and its subdirectories are used by many system utilities services. They're often consulted or invoked when the system starts and stops services or requires their status, right? On Red Hat Enterprise Linux systems, when you do ls etc sysconfig, you will see some related information there. We can take a look at one file by doing cat etc sysconfig se linux. This file reads and sets the se linux configurations at system startup. Okay, etc default. The etc default directory on the Ubuntu system, the use of this directory is similar to the Red Hat's etc sysconfig, right? The files are used to provide extra options when starting a service. They typically contain code to set environment variables. For example, the file etc default user add sets the defaults that are used when new user accounts are being created. All significant Linux distributions, including Red Hat-based ones, now have etc default, even if they still have etc sysconfig. Shutting down and rebooting. Shut it down is used to bring the system down in a secure fashion, notifying all users that the system is going down, and then stopping it in a graceful and non-destructive way. After it is shut down, the system is either halted or rebooted, right? You can see some shutdown examples here showing on the screen. The options can easily be listed by built-in help messages, right? With no options example shutdown now, the default behavior is to power off the system completely. Some distributions such as Ubuntu violate this and go to single user mode instead. There are also the legacy command are reboot, halt, and power off, which may veteran users use frequently. Okay, this is the end of this video. Thank you for watching. I'll see you in the next one. Bye for now.